Hey guys, Mr. Moscato with you again. All right, so in the last video, we figured out how to draw a graph of a linear equation by figuring out the x and the y intercepts. All right, two easy ways to do it, right? Where does the line cross the x-axis? Where does the line cross the y-axis? Connect the 2 points, and we're good to go. All right. That works in a lot of different situations. Sometimes we need to do something a little bit different. So what we're going to do here is we are going to graph a linear equation by making a table. All right, so if we have a linear equation and we want to draw a line, all right, but maybe the x and y intercepts aren't necessarily easily obtainable, all right, or we just want to look at something a little bit differently, all right, then what we can do is we can pick some values for x and see what those values, what the corresponding y values are. All right, so we're going to take a look at a linear equation in a little bit different form. It's called a slope-intercept form, all right, which we'll figure out how to manipulate and play with later on. All right, when we're trying to figure out behaviors of graphs. But for right now, we're just going to use the slope-intercept form. I'll present it to you guys. It's a nice, easy way to get y by itself, and then we just plug in a value for x, and off we go. All right, so give me a second while we switch over here. All right, guys, so we're at the bottom of page 158, all right, and we're going to graph by making a table, right? So they give us an example here, graph y equals 1/3 x plus 2. All right, so basically what happens is we're going to pick some values for x and then see what the corresponding y value is, all right? So they pick 4 different x values. They pick -3, 0, 3, and 6. All right, so for -3, they get y equals 1. For x equals 0, they get y equals 2. For x equals 3, they get y equals 3, and so forth. All right, and that gives them xy pairs, all right, which they then plot on the graph there, all right, and then they connect all the dots with a straight line, and that gives them the line. Okay, so making a table is fine. Usually, when you make a table, you want to pick up 3 or 4 different x values. All right, just to make sure that your math is correct. All right, and just plot out the points, connect them all with a line. And if all the points fall on the line, then you did the math right. Really, as I said before, you really only need 2 points to draw a linear function. But sometimes we'll draw a table, or we'll create a table with 3 or 4 points, just to make sure that we're doing the math right. And the table can be a little bit more descriptive in terms of what's happening as x is getting bigger. What's happening to the y value? Is it increasing? What's the rate of increase, or what's the rate of decrease? That sort of thing. All right, so you guys can take a look at that example 5 on your own. All right, what I'm going to do is I'm going to take a look at example 5a. Okay, so 5a gives us 2x minus y equals -2. Now, we talked about the slope-intercept form of a linear function. The slope-intercept form of a linear function takes the form y equals, right, and we're going to use m, right, mx plus b, okay? This is the slope-intercept form. Okay, some of you guys are familiar with this. Okay, so the y by itself, okay, so y has to be positive and by itself, okay, or in other words, y can't be multiplied by a negative number. That's what I mean by y has to be positive. All right, y equals the slope times x plus the y-intercept, right? So that's what that means. We're not going to get into that right now, okay? But just understand that where standard form is ax plus bx, ax plus by equals c, the slope-intercept form of a linear equation just basically describes the exact same thing. It's just an easier way to put in an x value and get out a y value, right? So if we change the appearance of the equation right away, all right, we can drop x values in and then very easily get out the y value without too much more algebraic manipulation. All right, so what happens here? All right, so let me just erase this real quick. All right, so again, we want to get it into, we want to get y by itself, okay? That's how we put it into slope-intercept form. All right, so what happens here? I want to get rid of the 2x over on the left-hand side. So I'm going to subtract 2x over here. I'm going to subtract 2x over here. All right, and I'm going to get negative y equals, right, and I'm going to put the x first, all right, negative 2x plus 2, all right, I'm going to combine those two values, okay? Now, what happens over here on the left-hand side is that I have a negative y. Y has to be by itself. I can't be multiplying it by a negative y. So what I'm going to do is I'm going to multiply the left side by negative 1, which means that I'm going to multiply the right side by negative 1 as well. Okay, so negative 1 times a negative y gives me just y. Okay, and then negative 1 times, right, the quantity negative 2x plus 2, we distribute the 1 through the parentheses, right, so that gets multiplied that, and that gets multiplied by that, right? So negative 2x times a negative 1 is a positive 2x, and then a positive 2 times a negative 1 is a negative 2, okay? So this is our equation, okay? And we're going to go ahead and create a table of values here. All right, so let me just draw this up real quick. So I have this, and I have this, and I have this, right, and I have this. These are going to be my x values over here. All right. These are going to be my y values over here. Okay. So let's pick some x values. Okay. So if x equals 0, all right, so we're going to say, okay, the first value I'm going to put in, let's put in x equals 0, all right, so y equals 2 times 0 minus 2, all right, so y equals 2 times 0 is 0 minus 2 is negative 2. So when x equals 0, y equals negative 2, okay? Let's pick another value, right? If x equals 1, what does y equal, right? So if x equals 1, y equals 2 times 1 minus 2, okay? So y would equal here 2 times 1 is 2, minus 2 is 0, y equals 0, okay? So when x equals 1, y equals 0, and let's pick one more point. Let's say that x equals, let's jump ahead a little bit, let's go to 3. What happens when x equals 3? Okay, well, if x equals 3, right, we'll write it over here, y equals 2 times 3, right, minus 2, so y equals 6 minus 2, y equals 4. So I have three points. Okay, remember that my xy, remember that my xy over here, all right, is the combination of the x and the y points. So 0, negative 2, 1, comma 0, and 3, comma 4. So I'm going to plot those, right? I'm going to plot those 3 points, okay? So we'll plot 0, comma 2 first, right? So 0, negative 2 is going to be down here, okay? 1, comma 0, okay, is going to be x equals 1, y equals 0, okay? And then x equals 3, 1, 2, 3, y equals 4, 1, 2, 3, 4. Okay, so we have those 3 points there, right? So let me go ahead and label these. So this is 0, comma, -2. All right, this is 1, comma, 0, and this is 3, comma, 4. Okay, so I'm going to get my straight edge and see if we actually did draw or create a linear graph. All right, so what we're going to do is just connect the three points here. Okay, and there we go. All right, that is the graph of my equation 2x minus y equals -2, which we rewrote as y equals 2x minus 2, right? Slope-intercept form there. Okay, pretty straightforward. All right, you can do number 5b and number 5c on your own, and then